You think of yourself as someone who asks the big questions. You look up at the night sky and you feel it. That pull, that ancient tug in the chest that tells you there is something more out there, something enormous and patient and indifferent, and you brave, curious soul, you lean into it. You call yourself a thinker, a seeker, someone who does not flinch at the hard stuff. But here's the thing nobody tells you. Most of us who think we are asking the big questions are actually just standing at the door of the biggest question ever posed by any mind in the history of this species, and we have not even knocked yet. Let me put it this way. The universe is about 13.8 billion years old. It contains somewhere between 200 billion and 2 trillion galaxies, each one packed with hundreds of billions of stars, many of those stars orbited by planets. Many of those planets sitting right in that cozy zone where liquid water can exist, where chemistry can get weird and interesting, where something like life might just decide to show up and start asking questions about itself. The math, if you do it honestly, and you really should do it honestly, because the universe does not care about your comfort, the math screams that we should not be alone, not even close to alone. The cosmos should be absolutely roaring with voices, with signals, with the electromagnetic fingerprints of civilizations burning their way through the dark, and yet silence. Perfect, aching, terrifying silence. That silence is not just an interesting puzzle for scientists in lab coats to chew on over coffee. That silence is the most important thing you will ever sit with in your entire life, if you let yourself really sit with it. Because what that silence might mean, and this is where it gets genuinely frightening, is that something, some filter, some wall, some catastrophic inevitability has been quietly erasing civilizations before they ever get the chance to say hello. And the question, the one that should keep you up at night in the very best possible way, is whether that filter is behind us or ahead of us. Pews, let us start somewhere you already know. Picture a night, a Tuesday in October, somewhere far enough from the city that the light pollution finally surrenders. You're lying on your back on cold grass, and the ground underneath you is hard and real and smells like earth and damp leaves. You look up. The Milky Way is doing its thing across the sky, this slow diagonal smear of ancient light, and your brain, that remarkable 3-pound lump of electrochemical magic sitting in your skull, starts trying to process the distance. It cannot, not really. It can say the words, it can recite the numbers 200,000 light years across, 400 billion stars, but the actual feeling of those numbers, the visceral weight of them, just slides right off. Your brain was built for a savanna. It was built to track antelope and read the faces of people it loves and figure out when the rainy season is coming. It was not built for this. And here's the thing that Feynman, that grinning, bongo-playing, Nobel Prize-winning force of nature from Far Rockaway, Queens, used to say about that gap between what we can calculate and what we can truly feel. Not knowing is not a failure. Not knowing and staying curious anyway, and refusing to paper over the gap with a comfortable story. That is the whole game. That is the only game worth playing. So you're lying there on that October grass, and the sheer scale of the thing above you starts to press down on your chest a little. And maybe just for a second you feel it, that vertiginous, stomach-dropping sensation that you are a thin biological film on a rock orbiting an unremarkable star in the unfashionable outer arm of a perfectly average galaxy, in a universe so vast that the word vast is almost insultingly inadequate. And then, almost immediately, your brain does what human brains have always done. It reaches for a story to make it okay. Maybe we are special. Maybe there's a plan. Maybe someone is watching. Maybe we are the point of all this. Bueno, here's where the science gets uncomfortable. And here's where I want you to stay with me. Because what comes next is not meant to crush you, it is meant to wake you up. If you found this kind of thinking electric, if you already feel that buzz in your chest that says this matters, then do something about it right now. Hit that subscribe button. Not because some algorithm told you to, but because you're making a decision, a conscious, deliberate choice to keep this kind of thinking in your life, and leave a comment below. Tell me, when you look up at the night sky, what do you feel first? Fear? Wonder? Loneliness? Something you do not have a word for yet, because I want to know, and honestly, the answer might surprise you about yourself. The universe is big enough for all of those feelings at once. Now, back to the silence, because the silence is not finished with us yet. In 1950, a physicist named Enrico Fermi was having lunch at Los Alamos National Laboratory with some colleagues. The conversation drifted, as it does among physicists, to the question of extraterrestrial intelligence. And somewhere between the soup and the main course, Fermi looked up and asked in that deceptively simple way that only the truly brilliant can pull off. But where is everybody? That question, 3 words that could fit on a fortune cookie, is now called the Fermi paradox. And it has been quietly driving astronomers, physicists, philosophers, and anyone who really thinks about it absolutely crazy for decades. Because the math is not ambiguous. The galaxy is old enough, roughly 10 billion years, and large enough, roughly 100,000 light years across, that even a civilization expanding at a fraction of the speed of light could colonize every star system in the entire Milky Way in a few tens of millions of years. That sounds like a long time, but in cosmic terms, it is a Tuesday afternoon. In the roughly 4 billion years that complex life has existed on Earth, a spacefaring civilization could have crossed the galaxy back and forth hundreds of times, and yet still no visitors, still no signals, still no megastructures, no Dyson spheres swallowing the output of entire suns, no ancient automated probes parked in our asteroid belt, no directed radio transmissions encoded with prime numbers, just this profound, maddening, beautiful silence. Dejam pensar un momento? Because there are explanations, and some of them are reassuring, and some of them are absolutely not. Some scientists argue that intelligent life is simply incredibly rare. So rare that we might be the only example of it in the observable universe. This is called the rare Earth hypothesis, and if it is true, then our existence is not just remarkable, it is a kind of cosmic miracle that comes with an enormous responsibility. Others argue that civilizations inevitably destroy themselves before they develop the technology to communicate across interstellar distances. Nuclear weapons, engineered pandemics, runaway climate change, artificial intelligence that decides it has better things to do than keep us around. The list of self-inflicted extinction scenarios is long enough to be genuinely sobering. And then there is the great filter. This is the concept I have been circling around, the one I promised I would name. The great filter is the idea, first articulated by economist Robin Hanson in 1998, that somewhere along the path from simple chemistry to galaxy-spanning civilization, there is a step so catastrophically difficult or so reliably lethal that almost nothing gets through it. Almost nothing. The filter might be behind us, somewhere in the near-miraculous sequence of events that led from self-replicating molecules to eukaryotic cells to multicellular organisms to nervous systems to language to science. If the filter is behind us, congratulations, we are extraordinary survivors. And the road ahead, while still dangerous, is at least open. But if the filter is ahead of us, aver. This is where the cold sweat starts. If the filter is ahead of us, then all those civilizations that should have filled the galaxy with noise never made it to the next level. They hit the wall. And we are hurtling toward it right now, not knowing it is there. The way a driver accelerates toward a bridge that has been out for years. Espera, because I want you to feel the full weight of this before we move on. This is not science fiction. This is not a thought experiment for late-night philosophy students. The conditions that could constitute a great filter are real, they are measurable, and some of them are already visibly developing in our civilization right now. The proliferation of weapons capable of civilizational-scale destruction is not a hypothetical. The degradation of the information ecosystems that allow a society to make rational collective decisions, replacing evidence-based reasoning with tribal mythology dressed up as news, is not a hypothetical. The acceleration of technologies whose second and third order effects we do not understand and cannot currently predict. That is not a hypothetical either. And here's the part that ties it all together in a way that should matter to you personally. Every single one of those risks is made worse by a population that has lost the habit of rigorous, honest, humble inquiry. Every single one of those catastrophic possibilities becomes more likely in a world where people stop asking uncomfortable questions, stop tolerating the discomfort of not knowing, stop demanding that their beliefs be updated when the evidence changes. Feynman used to say that the first principle is that you must not fool yourself, and you're the easiest person to fool. That was not just charming advice for physicists, that was survival guidance for a technological species trying to navigate its own adolescence without blowing itself up. Bueno, so now you feel it, right? That knot, that low-grade existential pressure sitting somewhere between your sternum and your stomach, that sensation of the ground being slightly less solid than it was 5 minutes ago. Good. That feeling is important. Do not push it away. It is your nervous system correctly identifying that something real is at stake here, something enormous. But here's where I want to shift, because the whole point of this is not to leave you paralyzed. The whole point is to hand you something useful. Because Feynman, for all his talk about uncertainty and the limits of human knowledge, was one of the least paralyzed people who ever lived. He was joyful. He was relentlessly, almost irritatingly joyful. He played bongos in strip clubs and cracked safes at Los Alamos for fun and spent his summers in Brazil trying to understand samba rhythms from the inside. He did all of this because he had figured out something that most people never quite get. That uncertainty, genuine deep uncertainty about the nature of reality, is not a burden. It is a playground. It is the most interesting place in the universe to spend your time. Let me give you a case, a real one, that I think about often. A man, a researcher at a mid-sized university, call him by his work rather than his name. A radio astronomer who spent the better part of a decade scanning specific frequency bands looking for anomalous signals from nearby star systems. From the outside on a Friday evening in early autumn, the third week after the new academic year had started, he looked exactly like someone going through the motions. His funding was thin. His colleagues in other departments did not take his work seriously. At faculty dinners, he would get that particular smile people give you when they are being polite about something they consider a waste of time. He looked to every external observer like a man whose professional life was quietly failing. Inside, he was operating in a state of almost pure scientific ecstasy, because every day that he turned on his instruments and found nothing, he was learning something real. The silence itself was data. The absence of a signal at a given frequency from a given direction at a given sensitivity was a genuine constraint on the space of possible civilizations. He was not failing. He was doing science in its purest form, taking what the universe actually offers instead of what he wished it would offer, and building his understanding from there. That gap between how he looked, defeated, marginal, professionally embarrassed, and what was actually happening in his mind, methodical, rigorous, quietly exhilarated, is exactly the gap I want you to hold in mind. Because that gap is what good scientific thinking looks like from the outside when the culture around it does not value the process. And that gap is what we risk losing if we let the habit of honest inquiry erode. Now, let me give you the mental tools. Actual, practical, Feynman-approved ways of thinking about the cosmos that let you hold the terror and the wonder at the same time without your head coming apart. Because there are specific techniques here, specific habits of mind, and they are learnable. They are not reserved for physicists or people with advanced degrees. They are just practices like any other practice, and the more you use them, the stronger they get. The first one is what you might call comfortable uncertainty. Feynman was famous for saying, "I think I can safely say that nobody understands quantum mechanics." That is one of the most astonishing things a Nobel laureate has ever said in public, and he said it cheerfully, almost with glee, because he understood that the honest acknowledgement of ignorance is not a weakness, it is the beginning of every real discovery. The universe is not obligated to make sense to us. It did not set itself up to be comprehensible to a primate that evolved on a wet rock 4.5 billion years ago. The fact that it is as comprehensible as it is, that our mathematics works, that our physics makes predictions that turn out to be right, that our instruments can detect light that has been traveling for 13 billion years. That is the miracle. And it happened because people were willing to say, I do not know, and I'm going to sit with that until I do.
So practice saying it out loud if you need to.
When someone asks you what you think about some enormous question, about consciousness, about the origin of life, about whether we are alone, try saying, I genuinely do not know, and I find that thrilling. Watch what happens to your body when you say it. Notice whether your shoulders drop a little, whether your jaw unclenches. The posture of intellectual honesty is different from the posture of defensive certainty. One of them is exhausting. The other one is eventually exhilarating. The second tool is scale calibration. This is the practice of regularly, deliberately forcing yourself to confront the actual numbers of cosmology, not to be overwhelmed by them, but to let them slowly recalibrate your intuitions about what is important. Here's a number to sit with. The observable universe contains roughly 10 to the power of 80 protons. Your body contains roughly 7 times 10 to the power of 27 atoms. Every atom in your body was forged in the nuclear furnace of a star that lived and died before our sun was born. You're not on the Earth. You're not separate from the cosmos, looking at it through a window. You're a temporary local eddy in the flow of matter and energy that has been going on for nearly 14 billion years. And for a few decades, that eddy is aware of itself. That awareness, that thin, fragile, improbable film of consciousness, is the most remarkable thing we know of in the entire universe. Not because it is cosmically significant in terms of size or mass or energy, but because it is the only place we know of where the universe is in any sense, looking at itself. Feynman said it differently. He said that when you look at a tree, you see much more than just bark and leaves if you know what you're looking at. You see the photons from the sun being captured and converted into chemical energy. You see the water moving upward against gravity through a system of capillary tubes. You see millions of years of evolutionary refinement in every structural detail. The beauty does not go away when you understand the mechanism. It gets deeper, it gets stranger, it gets better. Pews, here's the third tool. And this one is the most important for navigating the specific terror of the Fermi paradox. Asymmetric hope. This is the practice of holding two things simultaneously. The first thing is the filter might be ahead of us, and that is genuinely serious, and it deserves our full attention and our best thinking. The second thing is if the filter is behind us, then we are among the most extraordinary survivors in the history of the galaxy, and that comes with an obligation to not waste it. Both of these things can be true. Both of them, in fact, should be motivating. If the filter is ahead, then the urgent work is to understand it well enough to navigate around it, which requires exactly the kind of rigorous, honest, humble thinking that science represents at its best. If the filter is behind us, then the urgent work is to become the kind of civilization that deserves to survive, to make contact, to eventually someday find out whether we really are alone out here. Either way, the answer is the same. Think harder, be more honest, demand more from yourself and your society in terms of intellectual courage. Let me tell you about a discovery, a real one, because the science here is not abstract. In 1995, a Swiss astronomer named Michel Mayer and his colleague Didier Queloz detected the first confirmed exoplanet orbiting a sun-like star. Before that moment, the existence of planets beyond our solar system was technically an assumption. A reasonable one, sure, but an assumption. After that night in October of that year, in an observatory in the Haute Provence region of France, everything changed. Within decades, using the Kepler Space Telescope and then its successor, astronomers cataloged thousands of exoplanets. They found planets in the habitable zones of their stars. They found rocky planets, watery planets, planets with thick atmospheres, planets around red dwarf stars that are so old they make our sun look like a teenager. They found, in short, that the galaxy is absolutely lousy with planets. The raw material for life is everywhere. The conditions for chemistry are widespread. The question of whether life exists elsewhere stopped being a question about probability and became a question about detection. And then the detection question started getting interesting. Because in 2017, a strange, elongated object tumbled through our solar system on a hyperbolic trajectory, meaning it came from outside, from interstellar space. They named it Oumuamua, a Hawaiian word meaning messenger from afar arriving first. It was cigar-shaped, which is unusual for a natural object. It was tumbling, and it exhibited a slight, unexplained acceleration that could not be fully accounted for by solar radiation pressure alone. Most astronomers concluded it was probably a natural object, a fragment of some distant solar system's geology. But the astronomer Avi Loeb at Harvard, one of the most credentialed astrophysicists alive, wrote a serious scientific paper suggesting it could, in principle, be an artifact of an alien technology. Not that it was, but that the hypothesis deserved to be taken seriously and tested rather than dismissed. The reaction from the scientific community was instructive. Some took it seriously. Many dismissed it not because the evidence ruled it out, but because the idea felt too strange, too culturally loaded, too much like the territory of bad science fiction. And Feynman, were he alive, would have had something very specific to say about that. He would have said the job of a scientist is not to protect the dignity of science from embarrassing hypotheses. The job of a scientist is to ask what the evidence actually supports, follow it wherever it goes, and be willing to be wrong in public. The willingness to be wrong in public is one of the rarest and most valuable things a human being can do. Espera, there is something even stranger to sit with here. The James Webb Space Telescope, launched on the 25th of December, 2021, is now giving us images of galaxies that formed less than 400 million years after the Big Bang. 400 million years after the beginning of everything we know, there were already galaxies, already structures, already the raw materials for stars and planets, and somewhere down the line, chemistry and life. The universe was in a hurry. It did not wait around. And when you look at those images, those smears of ancient light that Webb is pulling out of the infrared dark, you're not just looking at the past, you're looking at the conditions that have been operating in various forms across almost the entire history of the universe. Life has had a very long time to try in a very large number of places, and the silence in that context becomes even louder. Bueno, let me tell you what Feynman thought about the philosophy of all this, because it matters. He was deeply skeptical of what he called cargo cult science, the practice of following the forms and rituals of scientific activity without actually doing the hard work of honest inquiry. He talked about it in his famous Caltech commencement address in 1974. And what he said was essentially this: science is a way of not fooling yourself. It is a practice of building in checks against your own wishful thinking, your own pattern recognition gone haywire, your own desperate desire for the universe to be organized around your needs and preferences. And the civilization-level version of that same insight is this: a society that stops doing the real work of honest inquiry, that replaces it with the performance of certainty, that punishes doubt and rewards confident-sounding nonsense. That society is not just intellectually impoverished, it is existentially vulnerable. It loses the one tool it has for navigating a universe that does not care whether it survives. Dejam pensar un momento about what that looks like in practice. It looks like a species that invents nuclear weapons before it invents the international institutions capable of managing them. It looks like a species that develops the capacity to alter its own climate over decades, but cannot sustain the political will to respond to evidence on the timescale of election cycle. It looks like a species that creates artificial intelligence systems of rapidly increasing capability, while the philosophical and ethical frameworks for governing those systems are still in the draft stage. All of these are real. All of them are happening right now. And all of them become more manageable, not perfectly manageable, but more manageable in a culture that genuinely values rigorous thinking, honest uncertainty, and the courage to act on evidence rather than comfort. Here's the fourth tool: the practice of thinking in deep time. Human beings are not naturally good at this. We evolved to think on the timescale of a human life, maybe a few generations at most. The 7-year political cycle, the quarterly earnings report, the news cycle measured in hours. These are the temporal scales at which our emotional responses are calibrated. But the universe operates on timescales that dwarf these by factors of millions and billions. And the decisions we make now about energy, about technology, about what kind of thinking we value and fund and teach to our children, those decisions have consequences that will play out on timescales we cannot emotionally feel but can intellectually understand. Feynman had a beautiful way of making this concrete. He used to talk about the chain of knowledge, the idea that every piece of scientific understanding is built on everything that came before it, and everything that comes after will be built on what we do now. The astronomer who today is cataloging the atmospheric chemistry of exoplanets using Webb spectroscopic data is doing something that is directly downstream of every decision made by every physicist and astronomer and mathematician going back centuries. And the astronomer who in 100 years or 1,000 will look back at our era, will look back at what we chose to fund and pursue and value. The question is, what will they find? A civilization that was distracted at the crucial moment? Or one that looked the Fermi paradox in the eye and said, all right, we see you, we are taking you seriously, we are going to think harder. Pews, now we are finally at the word. The concept I have been dancing around since the beginning, naming it in pieces, approaching it from different angles. The word is not great filter, though the great filter is part of it. The word is not the Fermi paradox, though that is the container. The word is what Feynman himself embodied more completely than almost any scientist of his generation, and what the resolution of the Fermi paradox, if there is one, ultimately depends on. The word is curiosity, but not the casual dilettante kind, not the curiosity that flips through a documentary while checking messages on another screen. The deep, disciplined, structurally honest, rigorously maintained, existentially grounded curiosity that refuses to stop at the edge of what is comfortable. The curiosity that asks, why is there something rather than nothing? The curiosity that asks, if we are alone, what does that mean? And if we are not, what does that mean? The curiosity that asks, what are we actually doing with the improbable, temporary, astonishing fact of our existence? Feynman was asked once in a TV interview what he thought happened after death. He thought about it for a moment, genuinely, visibly, the way he thought about everything. And then he said, I think when you die, you are dead. And then he smiled, this enormous, unself-conscious smile, and he said, but I find that doesn't bother me because I had such a great time, and when I look at the universe and I see how it actually works, I find it much more interesting than any of the stories people have made up about it. The universe doesn't need to be organized around me to be worth caring about. It's already so much stranger and more beautiful than that. That right there is the antidote to the existential terror. Not denial, not false comfort, not a story about how we are special or protected or cosmically significant in some way that lets us off the hook. The antidote is genuine, grounded, scientifically honest engagement with what is actually there. The universe is 13.8 billion years old. It will continue for an almost incomprehensible amount of time after every star has burned out and every black hole has evaporated. In that context, your life is brief, my life is brief. The entire history of human civilization is a thin sliver of cosmic time so small that if you compress the age of the universe into a single calendar year, all of human recorded history would occupy the last fraction of a second before midnight on the 31st of December. And that is extraordinary, not devastating, extraordinary. Because in that fraction of a second, in that thin, improbable sliver of time, something happened that, as far as we know, has never happened before. Matter arranged itself into a configuration that could look outward and ask, what is all this? A configuration that could measure the expansion of the universe and find that it is accelerating. That could detect gravitational waves, ripples in the fabric of space-time itself, caused by two black holes merging over 1 billion light years away. That could build instruments sensitive enough to find a planet orbiting another star by the tiny wobble that planet induces in the star's motion. That could sit on cold grass on a Tuesday in October and feel, genuinely feel, the weight and the wonder of being here at all. Let me give you the last tool, and this is the one that ties everything together. It is the practice Feynman called the pleasure of finding things out. It is the deliberate, cultivated daily habit of approaching the world as if every single thing in it is potentially more interesting than it appears. The way water moves. The way a star forms from a collapsing cloud of gas and dust, heating up as it contracts until the pressure at the center is high enough to fuse hydrogen into helium, releasing energy that pushes outward against gravity in a balance so precise that it can hold for billions of years. The way your own brain right now is predicting the next word in this sentence before you have finished hearing it, and occasionally getting it wrong in ways that tell you something about how prediction and perception are woven together at a fundamental level. The universe is not a backdrop. It is not scenery for the human drama, it is the drama, and we are not spectators. We are, for this brief and extraordinary moment, the part of it that is awake. Here's what I want you to take away from all of this. Not a set of facts, though the facts are important. Not a list of terrors, though the terrors are real. What I want you to take away is a posture, a way of standing in relation to the universe that is honest about its scale, honest about our fragility, honest about the genuine uncertainty of our situation, and simultaneously genuinely thrilled to be here for it. The Fermi paradox is not a question that has been answered. The great filter is not a threat that has been identified and neutralized. The silence of the cosmos is still there, still pressing, still waiting for us to get smart enough and honest enough to figure out what it is trying to tell us. But the fact that we are asking the question, the fact that we built telescopes and radio dishes and space probes and launched them into the dark on the strength of nothing more than curiosity and mathematics and the stubborn human insistence that the universe is comprehensible if you look hard, that is not a small thing. That is, in fact, the biggest thing we have ever done. Feynman used to end lectures sometimes by saying something like, "I do not know what is the matter with people. They do not learn by understanding. They learn by some other way, by rote or something. Their knowledge is so fragile." And I think what he meant was not that people are stupid, he never thought that, but that the habit of genuine understanding is fragile. It requires maintenance. It requires the courage to say, "I do not know," and mean it, and stay curious anyway. It requires a culture that values the question over the answer, the process over the conclusion, the honest uncertainty over the comfortable story. We are at a moment right now in the history of this species when that fragility is under genuine stress. When the information environments we inhabit make it easier than ever to find confirmation for whatever you already believe and harder than ever to find honest, rigorous challenge to it. When the complexity of the problems we face, climate, biosecurity, artificial intelligence, geopolitical fragmentation, exceeds the cognitive bandwidth of any individual and requires the collective intelligence of a civilization operating at its best. And when the silence of the cosmos is, in some sense, watching to see whether we are going to make it. Bueno, I think we can, not because I'm an optimist by default, but because I have seen what human curiosity looks like when it is genuinely unleashed. I have seen it in the faces of students encountering a beautiful equation for the first time. I have seen it in the data from the Voyager probes still transmitting from interstellar space, launched in 1977 on nothing more than the correct intuition that the universe was worth exploring. I have seen it in the image from the Event Horizon Telescope of the shadow of a black hole, the first direct visual evidence of an object whose existence was predicted by pure mathematics a century before we could see it. I have seen it in the sheer improbability of the fact that you're watching this, that you felt that pull when you looked up at the sky, that you wanted to understand something real about the universe rather than just feel comfortable inside a story about it. That pull, that tug in the chest, when you contemplate the scale of things, that is not anxiety. Or rather, it is anxiety, but it is the good kind, the kind that is indistinguishable from wonder if you hold it right. It is the feeling of a mind that is actually engaged with reality. And a mind that is actually engaged with reality is, in this moment of human history, one of the most valuable things in the universe. So go outside tonight, find a dark enough patch of sky. Lie down on something cold and real. Let the scale press down on your chest. And then, instead of reaching for a story that makes it smaller, lean in. Let it be as big as it actually is. Let yourself be as small as you actually are. And then notice somewhere under the vertigo and the wonder and the faint, delicious terror of it, a feeling that Feynman knew well, a feeling that has driven every real discovery in the history of science, the feeling of wanting to know, not needing to know, not demanding a comfortable answer, just wanting genuinely and without conditions to understand what is actually there. That wanting is the most human thing about you. It is also, if the Fermi paradox is trying to tell us anything, the most important thing about us. It might be, in the end, the thing that gets us through the filter. Not our technology, not our strength, not our ability to build weapons or walls or stories that protect us from the dark. Our curiosity, our stubborn, irreverent, joyful, rigorous, humble, magnificent refusal to stop asking what is out there. The universe is very old and very large, and as far as we can tell, very quiet. And we are here for this brief and astonishing moment, awake inside it, asking questions it has never been asked before. Feynman would have found that completely, unreservedly, delightfully wonderful. So do you?